Okay, it is the 23rd of May, 2017. We're looking at number 13 in the chapter review, part B. So you had to actually graph the solubility of silver nitrate, and we were given 0, 30, 40, 60, 80, and 100. And of course I did not do this to scale. It's fairly ugly, but did you create a graph? Okay, so if you created that graph, and I'm just going to put in fake data here, and it looks something like that. From your data, you've got a line of some sort. And from that line, you can then, they want it at 75. Well, you can estimate 75 using that best fit line. And your line doesn't have to totally match your data because it's going to be a best fit line. So it may not be a perfect line. You don't want to connect the points. You really want a line of best fit. And you just estimate. Does that make sense? Yeah. Okay. What I have for you next for our crazy example problem is one that was a late in the year, or maybe early in the year for a Chem 2 question that somebody had at a different school from another chem teacher. And I saw the problem and I thought, ooh, I want to save that. Because it pairs up a lot of stuff that we would do. The problem goes like this. What mass of sodium hydroxide is needed to precipitate all of the cadmium ions out of 500 milliliters of 0.75 molar solution of cadmium nitrate, producing the insoluble precipitate cadmium hydroxide? Ooh. Good Lord, what do you have to do to answer this question? Ah! Scream, run. .500 milliliters. Okay, what's your first step? Writing a balanced chemical equation. So I like this problem because it's a single problem that can pretty much be a final because it pulls in so many different materials from so many different units. So we know, what are our reactants? Give me one of the reactants. Anybody? Okay, I'm going to actually give you the reactants. So this is a double replacement reaction. The first reactant is sodium hydroxide, NaOH. We're adding this to a cadmium nitrate solution. So the second reactant is cadmium nitrate. If you had to predict products for this reaction, what would you predict? Well, it's double replacement, remember? So squares and circles partner up. What's your first product? Yep, sodium nitrate, NaNO3. And what's your other product? CdOH, cadmium hydroxide. Okay, now, so you got something like that. 2 moles of sodium hydroxide plus 1 mole of cadmium nitrate, cadmium 2 nitrate, yields 2 moles of sodium nitrate plus 1 mole of cadmium 2 hydroxide. Seem reasonable? Okay. Well, that's a good first step. Now, we're doing some stoichiometry. What mass of calcium hydroxide, or sodium hydroxide, is needed to precipitate all of the cadmium ions out of 500 milliliters of 0.75 molar solution of cadmium nitrate, producing the insoluble precipitate of cadmium hydroxide? Here's the part that you don't know yet, that we'll do next week. When we have two solutions, like a sodium hydroxide solution and a cadmium nitrate solution, they're both clear solutions, which means all of those ions are sort of free-floating. When we mix them together, if we get a precipitate, what it means is that one of the products that was formed is not soluble. So That's very soluble. It stays a clear solution. This is insoluble, and that's what it's saying. This is insoluble, and so it's going to precipitate out. So what we want to know is how much sodium hydroxide do we need to get every single bit of this cadmium to precipitate out. So the first thing we have to understand is how much cadmium we have to start with. How many moles of cadmium do we have if we've got 500 milliliters of a 0.75 molar solution of cadmium nitrate? Oh, well, moles equals moles over liters. Molarity equals moles over liters, and we want to solve for moles. Pretty easy. So molarity times the number of liters will give us how many moles of cadmium nitrate we have. We're told that we have a 0.75 molar solution, and then we have 500 milliliters, that's 0.5 liters of it. How many moles of cadmium nitrate do we have? Okay, so we've got 0.375 moles of cadmium nitrate, cadmium-2 nitrate. Now what we really want to know is what mass of sodium hydroxide do we need? All we're saying is what mass of sodium hydroxide do we need to fully react that? This goes back to chapter 9, Stoichiometry. Whew, easy for me to say. Goes back to chapter 9. This is just straight stoichiometry. So what we're really asking is what mass of sodium hydroxide do we need to fully react 0.375 moles of cadmium nitrate? Okay, that's not so hard, but it took us a little bit of our current knowledge to get to it. So we would set up a factor label, 0.375 moles CdNO3 2 times. For our mole ratio, we have to go back to the problem, to the reaction, the balanced chemical reaction. I'm going to try to enlarge and place over here. And what are our coefficients? So where are we getting our numbers? And we're already in moles, which is kind of nice because we don't have to do a mass conversion from the cadmium nitrate. So for every one mole, oh, that's not the balanced chemical equation. Silly Moser. For every 1 mole of cadmium-2 nitrate that reacts, how many moles of sodium hydroxide do we need? 2. So 1 to 2. And can we find the mass of sodium hydroxide? Yeah, easily. Okay, so at this point, our answer is going to end us up in, let's see, we cancel moles of cadmium nitrate, cancel moles of cadmium nitrate, cancel moles of sodium hydroxide. We're left with grams of sodium hydroxide, and that's what the problem's asking for. Raw answer, we need about 30 grams of sodium hydroxide to get all of the cadmium ions to precipitate out, to get all of the cadmium out of the solution. Okay. It's a good challenge problem. Honestly, I could see doing a problem like that as a bonus, where you have to incorporate material from a lot of different chapters. And in a case like that, you get some points for writing a balanced chemical reaction. You get some points for, knowing to figure out how many moles of cadmium nitrate we're talking about. So you get points for each piece of it. Okay, any other questions on the homework?